Good evening, ladies and gentlemen. Welcome and thank you for coming to watch my presentation. Tonight I'll be talking about how to split applications into separate tiers and why Symfony is a great tool for this. Now, before getting into the technical stuff, let's talk a bit about my favorite subject, me. My name is Arjen Swafs, and as you probably noticed by my accent, I'm Dutch. I've had over 8 years of experience using Symfony. Now, several years ago I decided I had enough of my plushy life in the Netherlands and decided to go traveling. That is until one day I arrived in this beautiful city known as Melbourne and decided to stay here for a while. Luckily, there was a company that was willing to take me in and offer me a job named Evolution 7. Now, what is this splitting up I'm talking about? Well, we're all familiar with MVC, as that is what Symfony uses, but that's not what I'm talking about here. Instead, what I'm talking about is splitting your application up into separate layers of functionality. For example, you have a CMS, and on top of that you would have the API layer, and on top of that maybe a web interface. Or, if you're so inclined, also a mobile interface, whether it's an app or just a mobile specific website. And all around that you have a lot of other layers or functionalities running from your database to a caching layer, third-party integrations, and some jobs you have running to the side. But why would you want to do this? You should probably notice just by looking at the image. It is a quite complex system. So why go to all this hassle? Well, there are several reasons for this, but I will focus on only two for now. First one is speed, especially when it comes to caching. Because you have the different layers, it is easier to have caching at the different levels as well. So not only at the top, but in between the different levels. This is especially important for high traffic sites and applications, as it allows you to scale much better. The other thing is flexibility. With everything much more independent, it's easier to spread the load or just have extra layers for things. You can do horizontal scaling much easier because everything is API driven, things like that. Of course, this has a little bit of overhead, but it has its advantages as well. For example, things become much more extendable. You can just add extra layers, an extra front end like that mobile version I mentioned. Now, and lastly, flexibility is because of the underlying technology. You no longer have to depend on any single method, any single way of dealing, any single language or framework. Instead, you can just use whichever is most useful for a specific layer. In the end, that means basically you should think differently about this application. More of a service-oriented architecture or even microservices way. Personally, I believe this is definitely where applications are headed in the future. However, this is a Symfony meetup, so we're not here to talk about the theory behind architectures or my visions of the future. So instead I'll be explaining why we found Symfony specifically so useful to achieve a split up application like this. Now, within Symfony, how would you split up your application? There are a couple of ways for this. First is to split up in multiple applications. If you're familiar with Symfony 1, you might remember that this was a very common way to do things. However, in Symfony 2 this is no longer a common way to do things. And in fact, it has become so uncommon that it has already been decided for Symfony 3 this will no longer be possible. Now, within Symfony 2 though, routing is a very common way of doing things like this. You can have several different groups of controllers which you will then give different prefixes or even different host names. Now, the last way to do it is to actually just create separate projects for each of the layers. This is my personal favorite because I think it offers you the most flexibility, but this obviously also means there's an extra overhead in making sure everything works together in a way that you would not have if you left it all within namely the same project. Now, as a use case, I will be talking about a football news site called Tribe of Football. As this is Melbourne, let me clarify that. I'm not talking about this kind of football. Instead, I'm talking about what I would call proper football, where the Netherlands beats Australia and people go around biting each other. Now, Tribe of Football is a fairly high traffic site. It has over 500,000 unique visitors per month and it has over 300,000 articles already. In fact, about 300 to 500 articles are added each single day as well. Now, when we were asked to do a redevelopment for this site, we had to make architectural decisions. The first of these, of course, was which method will be used. We wanted to build it as an end-tier application, as well as using Symfony for this. Now, so what we eventually came down to was a combination of routing and different projects, where we left the CMS and API in a single project with the web interface in a different project. Now, did we do everything in Symfony? Actually, originally, no. We decided that we would use Silex for the front end. As Silex is a lightweight framework based on Symfony components, we felt it was powerful enough for what we wanted to do. However, during the process, we discovered that we would need more functionalities than were easily available for Silex, and one of the strengths of Symfony is, of course, its bundles. For everything, it seems there's a bundle, and if we rebuild it into Symfony, we would not need to build our own layers on front or in front of any libraries we want to use, but instead we could use existing third-party tools for that. That's another reason as well, which I will come back to in a bit. Now, so how did we end up doing this? First, the infrastructure. We're running it all on AWS. Now, as we've had several presentations in the past about this, I am not going to go into any details about this. In fact, let's just say we're using a lot of the services. Let's talk instead about caching. Now, with caching, we've had a presentation about Symfony and caching not that long ago, so I won't go into too much of the theory about it. Now, with end-tier application, you would have your application on top of that, maybe a varnish layer as well. However, the nice thing is that we can just plug in extra caching wherever we want. We could have a service like Cloudflare at the very top, and maybe a caching layer between the API and the web interface. Now, one of the great strengths of Symfony, and the other main reason why we switched back to using it instead of Silex, is ESIs. ESIs are edge-side include, and it basically allows you, when you're using a caching server like Varnish, to have separate parts of your page cached differently. Let me explain that for a bit. Say you have a simple page, an article, for example, and you cache that for 30 days because nobody ever changes it. However, on that same page, you have a couple of sections, like a top stories or a read count, things like that, that have to be cached at separate times, maybe for 10 minutes, maybe 2 hours. The details don't matter that much. Now, the nice thing with Symfony is that it has a method called render ESI. This is a twig function and allows you to transparently have ESIs in your on your page. Instead, the way this works is that if Symfony detects a proxy in front of your server, like Varnish, for example, then it will treat these sections as ESIs. Otherwise, in your development environment, it would treat these just as simple includes. As you can see, for an ESI controller, there's actually no real difference here. it's still the same thing. The only difference is that you set a shared max age instead of a regular max age for the caching period. With all these caching layers, that introduces extra difficulties with the invalidation. So how we solve this is that whenever a change is made in the CMS will calculate which pages this affects, and then for these pages it will create URLs in a queue. This queue is then watched by cron job. This cron job will then pass along these URLs to an actual Symfony command. It then loops over each of the defined caching services that we have and simply calls the purge URL method in those. The purge URL method can be as simple as this Cloudflare invalidator, where you only need to send a post message to the service itself. But as you can imagine, for example, when using auto-scaled varnish servers, this becomes a bit more difficult. Now, at the center of all of this is the API. In order to show you the extent of how this works, I will walk you through a simple single page call where we're ignoring all caching, by the way, as that wouldn't add any useful information in this case. Now, our example is to look at all the articles related to the local football or soccer club here, Melbourne Victory. Which means we go through, first we'll enter the Frontend Controller. Frontend Controller calls the Frontend API, which then in turn interacts with the API controller. Now, the API controller is assisted by a ParamConverter as well as a formatter. Now, what does this look like in code? With the Frontend Controller, you can see it's really a simple setup. We get the club by interacting with the API client. We are calling a getClub_slug method there, which makes this not look any different actually from when we would be using Doctrine instead. Now, for the API, we're actually using Guzzle. So the API client we saw a moment ago is just basically an extension of the default Guzzle client, which means that we can define all these methods in JSON files. As you can see here, we have the getClub_slug method, which has its parameter defined, as well as a URL that it will call on the API side. The base URL for this is of course configured elsewhere, probably in the parameters.yml. Now, at the endpoint of this API call would be the controller from the API side. Now, in order to keep these really as clean and lean as possible, they are all defined as services. In fact, you can see here that the only parameter provided to this class is actually the formatter. So, how does it then actually get access to the information? Here we see the actual methods we're using for this. As you can see, the root is the exact same as called by the API on the front-end side, but it looks very empty. And in fact, the parameter it provides is not the one provided by the root either. So, how does this work? Well, we're using here the ParamConverter. ParamConverters are a functionality from the Framework Extra bundle, where you provide a service and some optional options. How does it then actually look inside that service? Well, the service extends, or rather implements, a specific interface, and the most important method in there for our discussion here is the apply function. Basically what this does is, well, in this example actually, it will retrieve the club. If it doesn't find it, it will throw an exception. This exception, as it happens, would further on be caught and transformed into a more JSON-friendly version of the same exception. Now, however, if it is found, it will then be set inside the request attribute. As you can see, you provide an option with the name, which is the exact option that was provided in the earlier method, and in fact the name matches the parameter provided. The other reason why the controller is so empty is the formatter. The formatter is not Symfony specific, and basically all it really does is make sure that the result that we want is formatted properly, that it's an array and that it has all the different extra bits and pieces that we need to provide to the page on the other side. Now, that means we've walked through this whole stack now. And of course, in the end, the API controller returns this all the way through the stack to the Frontend Controller, which passes it on to a Twig template. That's all quite neat, and as you can see, each separate step in this whole process is not all that complex at all. There's just a couple more of them, but it's all quite nice and well testable because everything is separated and kept into little pieces. Now, of course, nothing is perfect, and that counts here as well. There are downsides, especially around the complexity, because yes, that is something that happens here, and it shows up in different ways that we've, at least as far as we have encountered. Now, the first of these is the development setup itself. Even if you're just doing front-end work, like changing CSS and JavaScript, things like that, you will still need need access to all these different layers. So you will need to have your own copy of the CMS API layer, which in turn requires the database. Of course, at a later stage in the process, you can potentially just hook up the front end to the production API, but this in turn has its own downsides because of the latency that you would have for each call to go all the way to the production API, which might be farther away from you. Now, the other thing is deployments. With deployments, you have to be really careful. In fact, they have to be in a specific order, and you have to make sure that you don't introduce any breaking changes. Everything has to be backward compatible. So you would start with your database, but you can't just remove fields that your CMS and API still depend on. Next, you would have to deploy that CMS API layer, but again, you can't remove anything there that the front end still depends on. And in turn, you couldn't deploy the front end first, for example, if you have any new features that might not be possible, that might not be available yet in the CMS and API. So this just means that you have to be very careful. Of course, if the front end changes don't involve anything with the API, then it's perfectly safe to just deploy it separately. Now, the last downside I will mention here that we've run into is that it can be slow. Yeah, I know. I mentioned speed as one of the big advantages of this whole process. Well, unfortunately, while that is true for the production interface, for the production version of the site, it is not so much the case for your development environment, especially because of these ESIs again. Now, let's explain this with an example. We have here a transfers page, which is just a standard page and shows a bunch of articles. However, separate pieces here are ESIs. We have the top menu with the popular stories thing at the bottom, and there's a read count for each of these stories. Even the ones where you don't see one, that just means they haven't been read enough that it was worth showing. Now, each of these calls, each of these ESIs means that an API call is being made. So even here, you can easily see maybe 30, well, maybe 20, 30 API calls. However, it gets worse when you go into, when you look into the main menu and you see that in there's a whole bunch of articles again. And these articles by themselves can have a read count, which of course calls the API. Now, in production, this is not an issue because all of these read counts and such will be cached. They will not need to make API calls. However, in development, it is quite hard to work on cached pages if you want to make any front-end changes. So instead, the only real way we found around this is to just simply hardcode the result for these page read counts. This is because these are the most numerous calls, so just taking that call out of the business is taking that call out of the schedule is the easiest way to do it. No, it's not pretty, and you have to be really careful you don't accidentally commit that, but it was the best thing we could come up with. Now, of course, there's good stuff as well. Basically, everything that I mentioned as a reason for why still counts. Those were the things we were hoping to get out of it, and we mostly got them. For example, the extendability is really useful. It was easy to add any extra layers, extra functions that might or might not need to depend on the main application. And also changing the Twig application to a Symfony application for the front end, that was really quick. The web interface, it took maybe 4 hours to change it. And the last really nice point here is the way the backend and front-end developers might work together. Because it is all API driven, the front-end developers did not need everything to be ready for their work to be done. They could instead simply use some JSON files with dummy data to get the same result, while the backend was working on properly implementing everything that needed to be done without having to rush in order to make sure that whatever the front-end developers needed the most was done. So yes, I would say we were quite happy with the result we got here. In fact, so happy that we did more projects with it. In fact, just today we launched one of our projects running a Symfony 2 backend and API. On top of that was an Ember application for doing the whole web interface. So, thank you all for listening and watching. My blog can be found at ignore.me, and if you want to contact me for any reason, you can find me on Twitter, GitHub, and a bunch of other services, all using the name Arjen Schwarz. Once again, thank you for watching.